I'm Rahul Dev and I will be presenting the overview on the installation of Tulip. And no, we are not talking about the flowers. It's a normal framework where it's make looks cool. It's an basically a graph visualization of software, open source software, where you can visualize more in graphs. Tulip was discovered at 1990 by the university students of France. The name of tulip represents the idea of beauty of visualization blooming the raw data. Uh, It was built for a research project and lots of numerical academic research and key features of tulip. It can handle very large graphs with millions of nodes and edges and efficiently. It provides powerful visualization capabilities with various layout of algorithms. It offers a plugin based architecture that makes it highly extended. It includes built-in algorithms for graph analysis like clustering, metrics, and pathfinding. It's available on Windows, Linux, and Mac. So we go with installation first. We will go with first Mac installation. Yeah, we are going to start in Mac. So you can find a Tulip tool in a source for G. You may download from here. So I click download. It started downloading. Yeah, I previously installed it in DMG model in Mac DMG. We can say after installing Tulip DMG, just double tap it. You can find version of Tulip 6.0.1.app. Just it transfer to application. Yeah, it started. Yeah, it's going to start installing. Yeah, you can see. Yeah, let's launch the Tulip app. It's loading. You can see the tool. Yeah, just I'm showing the interface of Tulip in Mac. Just see, I'm putting in small graphs. Yeah, social network. You can find. Okay, you can find different names. I'm going with the ball boss model. Okay, yeah, you can see the nodes and connection between the nodes, and you can see the algorithms, clustering, and topological test, and you can find anything you need, heuristics, curve edges. Yeah, you can, I'm basically clicking the cut edges. Yeah, it's loading very, it's totally too many nodes, right? So it's loads. Yeah, you can visualize. Yeah, I want to show. Yeah, oh yeah, one more I need to show the panel Python. Yeah, it's opening. Yeah, owning. Okay, it's come. I don't think so. Yeah, Python interpret. You can use like as in Python print. Hello Dev. So it's cam and yeah. So now we are going to install in Ubuntu. So present we are going for source and website where you can find open source projects of files. So here you can see the download. Just click it. I had click it download. So it started downloading. So you can check a path of your file where you can save it. Just download. Now after I already installed the Tulip. So first to open Tulip you need to use this command. So type enter command plus x tulip dot tap enter. So then type this command dot slash tulip enter. So it started installing and it launches. So I will give the overview of Tulip where you can find more. It can handle very large graph with millions of nodes and edge efficiently. It provides powerful virtualization. Focusing on large data, technical stacks are it basically built by the C++, which may fast procession. It's focus on large networks. It was built by C++ code by the better performance and GUI for user interference. It builds by the Python scripting for automation and rich visualization of mapping, customizes nodes and shapes and colors and label basic data sets and data properties. Timeline supported visualize how network evolves over time. Parallel coordinators views from multiple variables and data analysis. So we come with real world applications where we can find Tulip is more useful. So we are going to deep into architecture, core architecture. Tulip is primarily written in C++ for higher performance and efficiency. It used in modern architecture with a core library with plugin systems. The backend is designed with handle graphs with a million of elements without performance degradation. The architecture flows a model view controller pattern for the cleaning separation of concerns. The core library contains all fundamental graphs, operations, and algorithms, etc. Thread safe operations allows for the parallel processing of graph computing. Graph data with nodes and edges properties and heuristic. So we are going, so we can see the core architecture. After we are going for data structures, how it was written, data, I mean backend details. So how the property based algorithm has been storage, support from the nested subgraphs and clusters, filtering and in heuristic mechanism, OpenGL, rendering engine, etc. We are going for into this. So basically we are going with starting with plugin system. The plugin system was started with the backend provides where API for the developing customer plugin. Plugins were also written in C++ or Python. So Plugins are dynamically loaded at runtime for the designed plugin directories. Each plugin has metadata including name, authorities, description, and dependencies. The plugin architecture uses faculty patterns for the installation. So after that, we are going with the rendering engine. Tulip uses OpenGL for a hardware acceleration for 2D and 3D rendering. It rendering backend supports level of details for smooth interactive with large graphs. Texture management for nodes and edges. Anti-aliasing and transparency support for high quality visualization. Camera control for pan, zoom and rotating in 3D space. Find the multiple algorithms in inbuilt in this application where you can find circular tree layouts, heuristical force directories, measures, clustering, coefficient, degree distribution, etc. So you can find also many type of it. You can go and explore from it after installation. So file, it also exports file format and import from export supports like GML, GraphML, .json and CSV, where we can also find export supports. We can SVG, PNG for the image. Like we can also use measure PDF and vector graphic. So my friend Paritosh will go on with the front end and extensible, etc. He will explain about front end.
So hi everyone, I'm Paritosh. So I will take over Rahul. So now we will see our front end and front end of our Tulip software. And so Tulip provides multiple link views such as graph views, matrix views, histogram view, and scatter plots. These views are synchronized, means we can select or modify something in one view, the change is reflected in other views. This helps in interaction and detailed visuals of complex networks. But Tulip also provide styling in color, size, shape, label from properties. For example, node can be colored according to community structure or size according to degree, centrality. This make visualization more meaningful. Now, another important feature is extensibility. Tulip supports plugins for layout, matrix, importers. Now, these are well written in C++ and Python. Now, if a required layout algorithm or metric is not available, users can implement their own. It also includes a Python scripting interface which allows automation and customization of workflow. So let's see on Tulip. I open, let me open Tulip terminal. It's loading, and yes, here it is. Okay. So this is how our Tulip software interface look like. As you can see here, there is an import section, import, export. So I have created, let's click on it. So we can create an empty graph. We can also create an pre-existed graph from which are common files in GML and CSV. So let me choose GML. I've already created using GPT. Let's see, let me load simple graph first. Yes. Okay. So this graph is of total 8 nodes. as you can see here. Now the we can also calculate uh, so I was talking about we can so change let me select this node 7. We can view its color and also change color of this node. Let's see, okay, it's changed, and we can calculate our various parameters that we studied in our class as between centrality, clusters, degrees, eccentricity. Okay, so there was we can view our graph in different ways. So first we need to calculate degrees of each node, then only we can have different views. Just click on it, and if I roll here, view metric. In view metric, we can see all the values. Let's say I click a degree. All degrees have 2 here. You can see betweenness, cluster, eccentricity. So let's say let me choose to degree. Then we need to go here and add panel. We can do a histogram view. Okay. And properties into select view metric, nodes, cross here. Okay. View metric, and yeah, our histogram is here. Now, if I select one node, it will highlight here. If you can see, we right click, select this node. Okay, let me load a bigger graph. Gmail. Yes, I saved it. I've already created using this GPT. Okay. Okay, let's load this large graph here. Open. Okay. Okay. Let's calculate its degree. You can see in view metric. Okay, it's okay. There's no edges connected here. Then we go to add label, histogram view. geometric properties. Okay, as you can see, there's no edge between any nodes, so Ceram is at 0 only. Going to next part, input and output formats. We have already seen how I imported a GML file from here. Okay, now I'll explain input and output formats supported by Tulip. Tulip supports its native TLP format and also common formats like GML and CSV. This make it easy to import data from other graph tools. For output, Tulip allows exporting graphs in TLP format as image or as property table. That is ensure good interoperability with other systems and tools. Let's see here in Tulip. You can see in import, we have JSON, GML, CSV, TLP export. Moving to the next slide. Tulip supports different types of networks. It supports directed and undirected graphs, weighted network also, where weights are stored as edge properties. Tulip also support hierarchical and clustering graph, which are useful representing community, structure, or modular systems. And in terms of scalability, Tulip can handle large network with up to around 1 million nodes. And it also depends on hardware configuration. Moving to the next slide. Now let us look how Tulip handles temporal or multi-layer networks. Tulip does not provide a dedicated dynamic animation engine. However, time or layer information can be encoded as node or edge properties. And using filtering mechanisms, users can analyze specific time range or layers. So, while dynamic animation is limited, temporal analysis is still possible through property-based filtering. Oh yes, so let's explore one of the core feature, construction. So for this, graphs can be constructed by importing data from formats like TLP, GML, CSV as we have seen before. We can also edit it manually too, where user can add node, edges and modify properties. Let's see in our Tulip software. Closing everything. We can create it from import. As you can see here, there is an empty graph. Correct? Yes, we have an empty graph. Now, as you can see in this panel here, we have to add nodes. Click on it. Let's tap on this open Canva. We have added one node. You can add another node and click on any of the node and drag it to the other node. Like we have added an edge between these two nodes. Now let's add another node and connect it. We can also delete the node. Okay. Now additionally, graph can be programmatically constructed using C++ or Python, which is useful for large scale or synthetic network generation. As you can see here, you can switch to Python ID. Just click on it. Okay, load a Python interpreter. That's very famous. Hello world. Now, Tulip support flexible attribute types such as numeric, strings, categorical properties, making it suitable for real-world data sets. Now, Tulip provides a strong visualization capability, support multiple network types, allow flexible graph construction, and is highly extensible through plugins and scripting. Now, for further features, let Agastya take over me.
So guys, I'm Agastya Nath and today we'll be exploring how to use the tool Tulip, which is used for graph visualization. So first we'll be covering one of the core features, which is metrics. So by metrics we mean values related to the graph, such as degrees, betweenness, centrality, closeness, all that we can measure from the graph through plugins, either through GUI or through Python. So we can use multiple algorithms such as clustering, community detection algorithms such as Louvain or whatnot. And there are multiple other measures which are path-based and connectivity, which we'll be exploring right now. Such as, if I had to show you an example, here we go down in the algorithm section to betweenness centrality, and if we go to results and click on view metric, it will be calculating all the values of all the nodes, all the betweenness centrality for each nodes, as you can see. And then we can also color by centrality as well. So for example, if I want all nodes whose centrality value is above 0 but less than 8306, then it's shown. But if it's less than 8306, such as 2210, then as you can see the values, and hence the coloring is changing. So this is one way we could do this. Also, we can plot histograms as well, distribution plots of different properties of the graphs. Another core feature is layouts and visualization. So there are multiple ways of laying it out, such as this one uses, I guess, it's written here somewhere only, the FM cubed OGDF. If it doesn't, we can work it out. See, yes. So now, as you can see, the graph got changed to the algorithm being applied, which is FM cubed OGDF, which is developed by Hachul and Junge. So it is a multi-level force-directed layout algorithm, which is usually applied to very large graphs. There are multiple other algorithms as well which we can use with this tool, and they are access to multiple layouts not only through GUI but also through Python as well. And for example, if I had to change it, as we will see, one of the layout algorithms being used through Python. So for example, if I had to use the FM3 from Python, we would say params is equal to tlp.get get default plugin parameters EFM 03 OGDF onto the graph, and then graph.apply lay out algorithm FMQ GDF onto the params. So as you can see, it changed again through Python as well. And you could get multiple coordinator views as well for the graphs and the plots. This is one of them. There are many other plots you could obtain from it as well. Next is scripting, which is a very main feature provided by Tulip. It provides scripting through Python. What does it mean? That Python console is embedded inside of Tulip. So what as I've been doing right now is that I've been entering all the commands in this console, in this Python interpreter, which is linked with the Tulip software. So one of the things I could do is I could check the number of nodes through this command. So 750. Similarly for edges, I could do this. There are a lot of other things we could do. Usually we could create batch pipelines as well, and then once the pipelines are created and we can create subgraphs, we can export as well. Like for example, if I had to create a simple graph, let's say I'm creating a new graph, g1 is equal to tlp is tlp supported, you have tlp dot new graph, and now n1 dot g1 dot add node. So seriously, there are 2 nodes in this, and then we create an edge. e1 is equal to g1 dot add edge n1 comma n2. Now we can save this graph. tlp dot save graph g comma let's say and if we want to open this graph, we could just go there and open, and then there you go, there's t2.tlp. So as you saw, just the new graph got open. We can also change this and apply the algorithm, the FM31. And it doesn't need any of changing because it already has the algorithm applied to it. And also do a lot of other stuff as well. So for example, we could color the nodes by their degrees. So for example, if we first let's obtain the array of degrees for each of the nodes. Okay, first let me open this one, I guess, not this one. As you can see, this is the one, and now I do the same thing only, but I'll obtain the degrees for each of the nodes in the graph. Now let's color them. Yep, as you just saw. So we just color the nodes by their degrees, and we can also do many other things as well. We can also integrate it with external Python ecosystem. I don't think it will work here because I haven't installed many, but if we had to check, yes, and normal numpy. I mean, it's not that impossible also. You can pip install packages from here as well. So for example, if I had to pip install numpy, so it will take some time because it's installing from the internet. Yes, so numpy just got installed. Similarly, if I had to install network X, so you can see it's very extensible. You can do anything with it as well. Also install packages and use them as well. So I just installed numpy. So we can obviously extend Python with many other packages, not only by installing them through pip, but also using them. So for example, I just in front of you pip installed networks and numpy as well. So if I do this, oh no, wait. Maybe I have to restart it again. So if I just do this, so I'm trying to use Python again. See, it just got imported now only, so you have to restart it as well for the effect to take place. So here you go. We can, so obviously we can integrate it with external Python ecosystems. We can also do any other things. For scalability and performance, obviously all the graphs, if you open them in Python, they are open in memory, whereas the GUI shows the graph, visualized for you immediately. But obviously this is only possible because the graph was being opened and laid out in the memory as well. So obviously for scalability and performance, it will be optimized in memory graph representation. And usually most of the time efficient rendering for large graphs such as sparse ones is usually done through OpenGL, which is a library for that. And it also, this along with this algorithm, this usually handles big graphs of magnitude 10 raised power 6 nodes and 5 into 10 raised power 6 edges as well, which is a typical scenario. Like in this case, we can see if we had to close this. So as you can see in front of you only, these are the typical kind of graphs which is usually handled well by this. Also, some algorithms can use multi-threading, and also with GPU support, you can also leverage that in order to efficiently calculate most of the metrics and values, and also color the graph or change its size by according to some metric. So, but obviously that is plugin dependent. You have to create a plugin for that in Python, but most of the time the efficient plugins are made in C++. Strengths, as we just saw, it has a very strong focus on large-scale graph visualization. If I had to open one of the innumerous ones provided as an example, so if I import, you can see there are multiple graphs you can open, not only from other formats but its own as well. So if I open, for example, say for example 20,000 nodes or 200,000. Guys, so unfortunately our algorithm took a lot of time and also huge space on our computer, as it took around 10 GB of RAM when it was implementing this algorithm on our 200,000 nodes graphs. So I thought of switching it up and going and opening a new project and importing just a simple general graph with 10,000 nodes and 10,000 edges. Yeah, so it's one graph example you can see in front of us. This is highly connected, and these are disconnected disparate components, which is obvious given the number of edges is equal to the number of nodes. supposed to be more than that for it to be completely connected, but this is one example we can see. So it can obviously, handle a lot of nodes, but not extremely huge number of nodes under technical computational constraints. For example, if you have 16 GB RAM, for higher RAM you can obviously handle a lot more RAMs for visualization, but when it comes to mathematics like centrality and all that, it could all do that really well in place in memory. Some of the strengths, as we just saw, it has a strong focus on large scale graph visualization and also a rich set of built-in layouts and metrics. Like for example, we just saw, there are multiple methods to use force-directed layouts. The one we are using by default is this FM cubed OGDF. Otherwise, we can also use Bertolt OGDF. So processing in progress. Obviously, it will take a bit of time, so leave that aside. If it works well, so later on we will see. And then it has, it's highly extensible via plugins and Python scripts. As we just saw, is it still processing? Okay, it will take some time. But if I had to take this example, for example, as we just saw, if I take the graph, also import Tulip as TLP, so obviously g dot number of nodes, it could show us the nodes and the edges. Some of the other fun stuff we can do as well is, for example, as I showed you how to color nodes by degree or any other centrality, we can also compute other centralities as well. For example, if I had to focus on calculating, as we just calculate degree of centrality, we can also calculate centrality such as betweenness centrality. So for example, bt is equal to g dot get double property betweenness. Yes. And then params is equal to tlp dot get default plugin parameters betweenness and now it's working. Obviously, params So for example, we can check for example, we have it at BT. For example, if we have to, for example, measure degree, it's taking some time, obviously, but you can obviously see with the many other scripts we have used. For example, if I had to so first we do this and let's check R and Gina graph. I'll do graph not yet nonce. Let's take another graph instead. And this is better, so I can use Yeah, no, it's fine. For example, if we had to use the GUI method, we can do this. For example, if we had to go to degree, yes, between essentiality. So as you'll see, go view metric. Yes, here you all the values of between essentiality are measured here only and stored here. If we have to calculate degree, it's all available here. Similarly, K cores, scalars, depth as well. But unfortunately, it's not acyclic. So yes, as we just saw, it has multiple ways of viewing the graph, multiple ways of input and output. Either you create one using Python only, or you import. Multiple formats are supported as well. So as you just saw right now, it has a very steep learning curve for new users. It's very sophisticated and not user friendly at all. It's very visualization centric, you just saw, but it only helps with calculating values of centrality and visualizing the graph through many other ways, through many other layouts as well. But you see, it's not fully fledged out that we can do ML or statistical heavy loaded work like we do in MATLAB or GNU plot or even NumPy and Python. So it's not fully fledged. So it has limited support for high level features and limited native support for animated dynamic networks, which you can do in Python as well, like with NumPy and Matplotlib. And performance definitely depends strongly on hardware. Use case one, if we had to use one, let's just use a social network. So for example, all these are social networks only. They model the network, that is it, nothing more than that. So if I make this 1000, so this is one social network being shown in front of you. You can obviously calculate all the metrics, centrality measures, or you can use Python interpreter as well, or you can do a lot of stuff with it. You can obviously color by community. So for example, these are all colored by their, if I'm correct. So for example, if I have to apply let's say degrees centrality, let's measure degree for all the nodes. It will obviously be stored in view metric. So as you just saw, and if we color by the metric each of the nodes, obviously, so if we keep it somewhere from 10.07 to 21, these colored nodes show nodes which have their degree between 10 to 21. So that's the interesting feature. So degree can measure how popular one person is in a social network, and we can easily see that here. Other is size by degree. We did size by degree, yes, size of the interaction. Color by community. So for example, how well connected you are, for that we use betweenness centrality. So we get the metrics here, and then here we change the size accordingly. So for example, as you can just see, it's the colored nodes as well, but if we reduce this as well, some of the nodes are also getting removed. So for example, if we change the bars here, what you see are the nodes which can be seen. Not only are they colored, that means they have their nodes in this range, but also the nodes which you can see, which basically means nodes which not only have their degree from 0 to 32833, but also nodes which have the centrality between 17937 to 32833. So that's the interesting thing. Oh, wait, is it a bit overlapping? So for clarity, let me just store the results in view rotation. So all the values of degree will be in view rotation. So if I do this, and if all the values of betweenness centrality will be in view metric. So let's do this. Coloring by degrees. So that is view rotation, and this one is on nodes. So as you can see, you still get the same result, which is basically nodes. So for example, if I do this, yes, so what it shows is all the nodes which have their degree from 2 to 21, but their centrality is between 11408 to 32833. There are very few nodes only which are not only colored but are big enough to be seen. So it implies that only. So that means these are the nodes which are not only completely popular, but also in order to get to someone else in the social network, you have to go through them a lot more times than with other nodes. So we just saw and observed hubs and community centers, which is very interesting. Second is protein networks. I don't think we have a graph which simulates protein networks. Yes, for now we don't have, but if we assume this to be protein network, even though it's a lot more, folded, a lot more complicated, and obviously not available to us, if we had to visualize protein networks, we can run centrality measures and other metrics as well, and apply force directed layout, which helps us in interacting and also plotting out how these forces between multiple proteins work, which helps us in studying not only protein denaturation and all the other biological processes happening at the cell level to the proteins, but also by using betweenness centrality, we can know which are the most important proteins which are worth studying, and also where are the hubs of these proteins, protein networks, sites, and all those stuff, and hence come up with better medicines as well. So as we conclude, I'd like to say that Tulip is a completely scalable framework for extremely large graph visualization and analysis, but only if you have the hardware resources for visualization of it. So it's best when the networks are really big and you just want values and metrics and visualization as well in terms of coloring and size, and that's it. Nothing much more than that, because then it comes to applications which need Python with NumPy and matplotlib and networks or MATLAB. This one is best for big graph visualizations and metric calculations, just as betweenness and all that. Nothing much more than that. So as I just told you, strength sites layouts, especially the force directed ones, metrics, extensibility, and visual analytics. That's it. So good choice for academic and research oriented network science projects. Nothing more than that. If you just want visualization of villages, of social networks in various areas, or just protein networks, and you want to visualize them, calculate values related to them. Nothing much more than that. So these are some of the websites from which we took references for our not only presentation but also for the demonstration as well. Obviously, we also took a lot of help from Wikipedia regarding the Python documentation. So That's it. That's how I like to end it. Thank you.